welcome back to my channel. I stopped abruptly from the other video, and now we're gonna do another example about limits as x get closer to 7. The function f of x approaches a certain limit. So here I've written it down. You can see limits as x approaches 7, goes closer to 7. This function here, there's no function here, so we are not going to have undefined values. So here we're just plugging the values directly here, and the way to do that, we just square this number here, which is 7, plus 7. According to this, you see this is 2x, means 7 times 2. Don't know what is getting this close, but minus the value of 8 up there. This thing is direct, we plug it direct. And then we do that, here we get 49 plus 14 minus 8. And that will give you this as the solution. Because we don't have fractions there, so we're doing direct, plugging in direct, unlike the other one where we have x squared minus 9 over x squared. Oh no, what was the value? Just hold on. From the previous video we were doing when there was x squared minus 9 over x minus 3. So this was a fraction, but here we don't have a fraction, and that's why we ended up with the undefined value 0 over 0. But in this case we don't have that, so we are going to do direct substitution. We're going to plug in directly and we're going to get the answer. So we can do various examples on this. Let's do another one. Now let's change this value. I'll write another one, there's no problem. You can write another one. I think that the red chalk is not so good, it's not so clear. Let's have a limit as x gets closer to 4, and then let's have the function which is x squared plus 2x minus something like 6. I mean, we are making these values from my head. I'm not really having a book or copying down, just making them from my head. So the limit of x as x gets closer to 4, this function f of x is called f of x. Actually x is a placeholder, and in this case it can represent that one. F of x approaches a certain limit. So what we do, direct, we plug in 4 directly here. So we're gonna get 4 squared and 2 into 4 minus 6. This value is directly plugging in 4, which is as you're getting closer to 4, this approaches a certain limit. So you see, now let's calculate this. Now 4 squared will be 16 plus 8 minus 6, which is equals to, you can actually do 16 plus 8, 14 plus 24 minus 6 is equal to 24 minus 6. What is 24 minus 6? That would be 18, right? So this will be the answer. Okay, now you can see what I've done. Limit as x gets closer and closer to this, that approaches a certain limit. So we directly plug in the 4, and when you square 4, it will give you 16 plus, according to that, what we are given there, 2 into x. It means 2 into 4, it will give us 8, and then minus 6. When you calculate this here, it's going to give you 18. So as a solution, so you can put in any value you want in this expression. You can put in, for example, 5. Let's have 5 here. And let me clean everything. There's no harm. Limit, let's give it limit 5 as x approaches 5. I'm getting confused. Approach and closer. As x gets closer to 5, the function over f of x approaches a certain limit. You see, this is an English problem here. So I've given now 5, and I'm taking the same expression. The expression can also change. For example, instead of writing x squared, you can write x cubed. But let's go by square, because we are already working with that. We don't introduce many things which can bring a lot of trouble. We can have something like 10, for example. I think it doesn't matter. We have something like that. So as these x get closer to 5, this thing approaches a certain limit. And let's do that direct substitution, direct. So we plug in 5 here. 5 squared will be 25. And 5 times 2 is 10 minus 10. If you know some maths, you know what this means. When you square 5, it will be 25. And 5 times 2 is 10 minus 10. So what's the solution? The solution will be, it's very easy. 35 minus 10 is going to be 25 as the solution. So you can see, you can give yourself various examples. You can put any value as x gets closer to that value. The function approaches a certain limit. So you can calculate the limits as by this formula. So yeah, so that's something about limits. It's an introduction. And I think I'm gonna go back to what we started and link these two things together, because you may not make a head of all tail of this, because the other video was interrupted heavily by noise. I had to stop it, but I'm gonna upload it anyway, so for you to see. It was this: as x approaches 3, the function x squared minus 9 over. I'm just showing you that these two are linked. X minus 3. We did this on the previous video, and in this also you can practice as x gets closer to 3, or you can say 2. Let's say 2. Let's change this to 2. And then we'll have hold on a minute. We can have x to 2. Now x squared minus something like 4. So when you square 2, what will happen? X minus 2, something like this. Direct substitution method. It will give you undefined value. If you calculate this, like this will be 4, it will be 0. To give you 0, and if you put 2 here, 2 minus 2 will give you 0, and this will become undefined. So you can go follow the same method or procedure to calculate for this. You can find a limit by plugging in a value closer to, but not exactly. For example, in this case, we have x squared. Guys, my voice is low, I cannot shout. You tell me to shout, I'm not able to shout. Naturally, I'm a low speaker. So I feel comfortable to stay in my zone of voice and try to be artificial shouting. So this, we get this. Now the function f of x would be, now you can guess what is gonna be the solution. So you're gonna plug in value which are closer to these two. Like I'll give you one example. I think I'll do this one, and yeah, I clean this one. Showing you that already. You watch the other video, you'll see what I mean here. 2.1 would be like 2.1 squared minus 4 into 2.1 minus 2. It's gonna give you 0.41 over 0.1, which will give you 4.1. It's just the same thing, like 3. You can give any value. So from here you can see that if you give a value which is like a 2.01, it's going to get even closer. It's going to give you the value, like you have to square this just the way we have done, and you do all that. I don't have to calculate this if you can follow that, but let's do it. Then it means I have to clean all this again. Oh man. Okay, let's do it. So according to that function, we have 2.01 squared minus 4 over 2.01 minus 2. And when you square this, I don't know whether I've done it anywhere here. I don't think so. Oh. Like I told you here, everything falls apart. Light is falling. Light is falling because of positive space. I didn't. So let's do it. So what is 2.10 squared? Chalks are running all over the place. Let me use a calculator. We have 2.01. You can tell that I'm not very comfortable with where I am, but we can do it anyway. So 2.01 times 2.01 is going to give you value which is 4.0401. And you can round it up. You see it's getting closer to 4. The other value we got was when you did 2.1, you got 4.1, but now we have gotten, you can round this one up. Okay, you can round this one up, then you get 4.01. You are getting closer and closer to 4, so 4 will be the limit. As this value x gets closer to 2, we are approaching the limit, which is 4. So you can plug in more and more values like that. That was the other thing we did before we switched over abruptly due to the noise factor. So you can give yourself various examples just to practice the limits, the limit of something, you know, what's the limit as this value gets closer to this number. So we'll proceed with this chapter. It's very interesting maths. It's called limits. Introduction to limits. For today, guys, I have to stop it here, and we proceed with this math. If you follow me, you'll see more about this topic. I'm sweating, it's hot over here. Okay, guys, this is a brief video. I think it's gonna be very brief, but it can be brief if you give yourself. I could give you more and more examples, but if you've seen what I've shown you, you can give yourself various examples. Like for example, you can give yourself limit as x adds to any number. You can say 8, 9, 10, whichever number, 3, 4, 5. Limit as x gets closer to 5 or to 6 or to 7, whichever number you put. Then the function f of x approaches a certain limit. Now that function could be in a fractional form, or it will not be in a fractional form. And if sometimes it gives you undefined value, not sometimes actually, to give you undefined values, then you will start getting, you can find a limit by plugging in a value which is closer to, but not exactly that number. And then instead of getting 0 over 0, you'll be getting values as you get closer and closer to that number. That's why we call it limits. So bye for today. Please subscribe to my channel, and yeah, I have to bring you more stuff, you know, and maths is one of the things that I've been giving you. So I'll continue with this if you follow me, and you learn a lot in terms of this is limits, introduction to limits. Okay, bye for today. Bye.